To make a simple graphical Linux distro, I'm going to use a couple of components and connect them together. I'm going to highlight on this stage of the video that it's not going to be an actual production distro that is intended for actual use, but mostly to actually just learn how stuff works under the hood and learn from the process. I'm not going to use something like Xorg or Wayland. I'm going to use something way simpler, but you're going to see it's going to be pretty cool. I'm going to show you some cool thing in the end. Basically, the main components are going to be the bootloader, which is going to start everything. The bootloader is going to start the kernel, so that's the second component. After the kernel, it's going to start the user space, and that is where we're going to use BusyBox. And finally, I'm going to put inside the window manager. And for this, I'm going to use a project that is called Micro Windows. I have here the website of the Linux kernel open, kernel.org. We're going to go ahead and grab the stable version from the website. Just going to copy the address of the tarball. And I'm going to start a Docker here. I'm going to start a Debian Docker. Just Docker run. Interactively Debian. Also important, you should pass in the privilege flag for this. Reason for that is we're going to mount something inside of the Docker, and for mounting stuff, you're going to have to use this flag. I'm going to run apt update here, and I'm going to get wget. Now I can grab the kernel, so I can run wget with the address that I just copied. Now I'm going to install a couple of dependencies that I need to actually build the kernel. I'm going to list all the dependencies on this video in the description. Let's go ahead and also install xz-utils so I can open up the archive of the kernel. Now I can go ahead and run tar xf on the kernel archive that we just downloaded from the website. Now let's go inside the folder of the kernel. I'm going to start by running make menu config. This will open a configuration menu for the kernel. I'm going to change a couple of stuff over there. First thing I want to do is go to the section that talks about the drivers. I'm going to press on D on my keyboard. That's going to bring me over here to the device drivers. I'm going to search for graphic support. I'm going to press G. We have a couple of stuff to change here. First of all, I'm going to change the fact that I want to use the Cirrus driver here. I'm going to press twice because first time it's going to write here M, and M is going to make this as a module. I want to actually include it inside the kernel, so I'm going to press again, and you'll see it turns into a star. And as you can see, star means that it's built in. This will enable me to actually use the Cirrus driver, which is one of the drivers that comes with QEMU, and we can use this driver to actually display stuff on the screen. Afterwards, I'm going to go down and enable frame buffer devices. Just enable this. Again, press twice for the star over here. Exit here. Also, another nice thing, I'm going to enable here the boot up logo so we can see the penguin while the kernel is booting. And finally, I'm going to also configure the mouse to be a device in the /dev. So I'm going to search here mouse dev, and I'm going to click on 1. By the way, I search with /. I'm going to press 1 here to select the first result here. And I'm going to enable this by pressing on space. And again, until it becomes a star over here. Now let's go ahead and exit the configuration of the kernel. And I'm going to save this. Afterwards, I'm going to run make -j and then 8. This will basically cause make to actually split into 8 jobs. And if you have a couple of processors on your machine, it can actually cause the build to be faster. Okay, so as you can see right over here, the kernel has successfully finished building. So let's just go ahead and copy this aside. I'm going to open a folder here. Let's call it distro. I'm going to put here all kinds of files that will be relevant for the distro. Let's just copy this to that folder. Now let's move on to actually build BusyBox. I have the website of BusyBox ready right over here. We just go ahead and grab the stable version from here. I'm going to again copy the link address. Let's extract the archive. Process here is pretty similar to the kernel. First you run make menu config. I'm going to just change one thing here in the configuration. I'm going to actually make this compile statically and not dynamically. Let's search for that over here. As you can see here, we can select if we want to build static binary. I'm going to say yes. Press on space over here, and let's exit. Now let's go ahead and build this. Again, make -j8. After it finished building successfully, I'm going to run another make command. This time I'm going to install. And I'm going to use the variable config prefix, and I'm going to pass in where I want to install BusyBox. I'm going to install it on my distro directory. Okay, so we're finished with BusyBox. Now let's go ahead and move on to the actual window manager. What's cool about this window manager is that it has also its own API, but it also supports the X11 API, and also it supports some of the Windows API, which is really cool. Also, another thing that I really like about this window manager is that the source code is very simple and minimalist, especially when you compare it to something like X11 or Wayland compositors. And setting this up is very simple. If you remember, one of the things I changed in the kernel configuration is that I enabled frame buffer support. And this will be very useful because micro windows can actually work with the frame buffer. Another cool fact before we continue on is that once there was a Linux distro that was called Nano-Linux, and this was very lightweight. It only required 14 megabytes of disk space, and it was based upon BusyBox and Nano-X, which is exactly what we're using for our distro. Let's go ahead and clone this project. So I'm cloning this from GitHub. I'm going to copy the clone address from here. Before cloning, I'm going to install a couple of more dependencies that I'm going to need for this project. Also, I'm going to need Git, and let's also install Vim so I can easily open the files for editing, and a couple of more dependencies. Now let's go ahead and clone the project. I'm going to navigate to the source folder. And here I'm going to open the README. As you can see, it's really simple to build this. All you have to do is just choose a configuration. You have a couple of options here. I'm going to choose the Linux hardware frame buffer. And this requires me just to type in copy for a configuration file from here. Let's just do that. After this step, you can see that all I need to do is just type in make. But beforehand, I'm going to actually change something in the configuration. That will be important afterwards. So let's open the configuration. And I'm going to search here for NX11. You'll find information about this in the README here, but I'm just going to explain this real quick. I'm going to change this from N to Y, from no to yes. And this helps me actually port applications that are written for X11 very quickly to run on Nano-X. By the way, I'm saying micro windows or Nano-X, both are referring to the same project. Now let's go ahead and run make. We have a little error here. I'm just going to fix this real quick. We need to just direct it to use the local X11 directory and not search for a system-wide X11. This will be very simple. I'm going to show you. Just go to the NX11 folder. And here I'm going to go to the make file. Let's search here for the X11, include. We're going to just comment this and uncomment this line. This just tells it to use the local X11 folder that comes with the project, that comes with micro windows. Okay, it finished building successfully. Now let's go ahead and actually install the libraries on my Docker so it can actually port an existing X11 application to run on micro windows. I'm just going to open the README again. Let's go to the section that talks about installing. We can see we can just use sudo make install and it'll just place the libraries and header files. Nice, so now after I actually installed the libraries and the headers on my computer, I can go ahead and actually port an existing X11 application to run on micro windows. I'm going to actually choose a very simple application that I actually wrote in a video about a month ago. Just a simple hello world application for X11. I'm going to show you the code right over here on GitHub. This is basically the code. Just opens a window and then it says thanks for watching inside the window. And this is written for X11. I'm going to just easily port this to run on micro windows. So I'm going to just copy over this code. Now before I'm going to actually build this, I'm going to open instructions from the micro windows project on how to actually do this. NX11 is the library that comes with micro windows, and this helps us port existing X11 applications to actually work on micro windows. As we can see, we need to actually link with these libraries, NX11 and Nano-X. As you can see, it's telling us that it doesn't know where to find the header file for X11. So I'm going to pass into GCC another include path with -i. This will go into the micro windows directory, NX11, and then finally X11 local, capital X. Nice, and everything compiled successfully, and I have a.out here. Let's just move this into my distro. Now let's go back to the micro windows folder. And before I actually copy the binaries from micro windows into my distro, I'm going to actually start by copying the shared objects that it depends on. For this, I'm going to run the LDD program on the Nano-X binary. As you can see, I now get a list here with all the shared objects that it depends on. So I want to go ahead and copy these to the corresponding directories on the distro. To make this easy, I'm going to open this in Vim. This line I don't need, so I'm going to delete it. I'm going to just record a macro here and clean up the lines. And turn these into copy commands. I'm going to run this on all the lines. This needs a special treatment, this line. I'm going to run this on this line as well. And actually another important thing, I'm going to create the directories. Let's also create the lib64 directory. Now let's go ahead and run all these lines. I'm going to just copy them into the terminal. Now everything is copied. I can close this, and finally I'm going to copy the binaries. Let's just go ahead and copy this whole folder. Also, we have a nice script here, so I'm going to copy it as well. It's called run app. Now we're finished with setting up the window manager. Final step is to actually set up the bootloader. And then this will close the boot image, and I can actually go ahead and boot this up in QEMU. I'm going to use the truncate command. Pass in the size of the boot image I want. Let's say, for example, 200 megabytes. Let's call it boot.img. Then I'm going to create a file system on this boot image. I'm going to use for this mkfs, makefs. This will just create a regular ext2 file system. I'm going to create a mount directory on this folder, and I'm going to mount the boot image on this directory. Notice that if you're getting an error after mounting, it means you haven't run the Docker in privilege mode like we did in the beginning of this video. After mounting, I'm going to actually install another dependency that I'm going to need for this. For the bootloader, I actually want to use something called extlinux. This is actually one of the syslinux bootloaders. It's a very minimalist bootloader, and it's fitting because we're actually using the ext file system for this case. Just run apt install extlinux. Finally, I'm going to go ahead and install the bootloader on my boot image, and I'm going to do that by installing it on the directory that I mounted it on, which is mnt. I'm going to pass -i for install. As you remember, we mounted the boot image to be in mnt, so I'm just going to move everything into the mnt folder. Now finally, let's create a couple of standard Unix directories inside the mnt folder. Now let's go ahead and actually unmount this. Now the boot image is ready. Let's go ahead and actually run this with QEMU. So I'm going to copy this boot image to my host machine using docker copy, docker cp. And let's go ahead and run QEMU. System x86-64. I'm I'm going to pass in -VGA cirrus. This is a VGA we want to emulate, if you remember from what we configured in the kernel. Afterwards, we're getting a message from the bootloader. It's asking us how exactly to boot this system. And the reason it's asking us this is we haven't actually made a configuration file for xz-Linux. So I'm going to pass in the kernel path, which is bzimage. And also I'm going to pass in additional kernel parameters. First one is going to be rw, because I want the file system to be rewrite. Afterwards, root equals dev sda. And this actually tells the kernel which device to mount as the root file system after the kernel finished loading. Now you can see the system has finished booting up. I can run ls, for example, it works. Let's go ahead and actually bring up the window manager. I'm going to do that by going into Nano-X. And I'm going to go ahead and actually start the server. I'm going to run for this Nano-X. And now you can see we have a black screen here. That's because I need to actually start a certain app. To actually start an app, I'm going to go to a different workspace by pressing Ctrl Alt and F2. This will activate a new console for me. Now I'm going to go again to the Nano-X directory. And here I can start whatever I want. Let's say, for example, I want to start Minesweeper, MW-mine. As you can see, we have a nice Minesweeper over here. We have a funny thing here with the cursor. Wonder what causes this. But you can see we can actually move the window. Press over here. It works nicely. And I'm going to go ahead and actually run the program that we ported from X11. That's the program that says thanks for watching on the screen. Let's go ahead and run this. Now let's go back into F1. As you can see, it prints thanks for watching on the display. Subscribe for more programming videos, and thanks for watching.